Hello. So in this section, we're going to look at binomial expansion. So that is expanding the bracket, right, any general binomial bracket, x plus a to the n, right? So a bracket that's raised to a power n, for positive integers n, into powers of n, obviously you have two numbers inside, right? In this case, x and a, right? Very general terms. But a binomial, which obviously leaves two terms in a bracket, we're going to be looking to expand that for any power of n. So obviously, for example, if we had to say x minus 2 squared, obviously you've looked at how we just expand it by times it by itself. If you had to the power of 3, we'll times it by itself 3 times and expand that way. But the problem is, what about for very large values of n? What about if we had to expand x minus 2 to like 15 or something like that? Expanding 15 brackets when there's progressively more terms at each term in each bracket. This is not efficient. It's really, really not efficient to do it that way. So there is an alternative way we can do that, which is the binomial expansion. And we've already developed a theory in the last two sections. To now, we're going to be looking to just execute it to be able to expand various brackets, various binomials with this method much more quickly. So, in general, we've looked at this already, vaguely, we've skirted around it, but when we expanded it, the expansion looks like powers of x, right? The idea is it goes in powers of x. So x is a 0, then we have x to the 1, which is just x. Obviously x to the 0 is just 1. X, and then we had x squared, and then we had x cubed, and so on to the nth power, because obviously it's to the power of n. So that's generally what our bracket will look like, right? But obviously there's going to be some coefficients as well. And we've looked at coefficients, so we looked at Pascal's triangle. So remember, Pascal's triangle looked like this. And each row gave us, corresponding to the power, gave us the coefficients for each term, right? Coefficients of each power, like that, and so on. But the problem is you'd have to keep going down Pascal's triangle. And again, for very large values of n, you'd have to go through many rows. So we looked at last time, something called a binomial coefficient, which looked like this. N, which you say in this sort of weird bracket notation, n choose r. Or alternatively n and then the c and then lowercase r there. And that gives us the coefficient straight away, which we then inputted in the calculator to then work out each coefficient part, right? So with that in mind, we've got the theory then to then be able to sort of generalise and give a method for expanding the general bracket. So we're bearing that in mind where if we have x plus a, say x is whatever, we want to go up in powers of x, right? As we just saw. So in general then, with this idea of this being the binomial coefficient, so the coefficient of each term we expand, for any general term, say the x to the r term, we know there's a coefficient part. Then we have the x term, right? X to the power of r. So we're in the rth part of the expansion. So x to the r, and then the other number a we add in as well in the bracket. So then we have to times by a. Then we need to times by the remaining power. So that'd be n minus r, because the idea is, remember, we want these two powers for the terms x and a. They need to add to n, right? The overall power of the bracket. Well, r, take away r is 0, then add n. So that's the idea, right? And so actually this coefficient then, well, it's just this, right? So for the rth term of x, right? this coefficient then would actually simplify to n choose r times x to the r times a to the n minus r. Okay, and that is it, right? That is basically what we'll be doing in this section. Is we're going to find the terms of each value of each x, right, of this bracket. And so because this gives the general term, well, we can find all the terms by starting from r is 0 to r is n, right? So what do I mean by that? Well, that we can start to give an expansion then with this idea, okay, for a general bracket x plus a to the n. And so this gives me the term for the rth term, right? But so then we're going to start from r is 0. That will give me the first term. So that's going to be when r is 0, n choose 0 times x to the 0. Now, times a. Now, that will be just to the power of n, right? Because then 0 add n is n. Now, remember, we start from 0, not 1 here, because we have a power. We have powers of 0, okay? Now, that x to the 0 is just a constant as well, but we'll leave it there for now. So that's the first term. Then we would have n to the n choose 1. That's the coefficient of the first term, times x to the 1, that's when the power is 1 for x. Then the other power for a is going to be then n take away 1. Then we do the next part, n choose 2 times x squared, so then now the power is 2. So r here, r in our binomial coefficient corresponds to the power of x, usually. Of the term we're working on. Anyway, that'd be x squared, and the corresponding power of a will then be n take away 2. If we then do n choose 3, then the power of x will be x cubed. Then the power of a would then be n take away 3. So we're taking away the power of x we've got. And it continues in this pattern, right? And so eventually it would get to n and then n, right? So when r is n, that will be the final term, because then the power of x will then be n, matching that. So there we are. And then the remaining power of a will then be 0, right? N take away n is 0. So there we are. And that's it, right? That sort of idea of how we can find, substitute all the values of r from 0 to n in the coefficients. This is how we expand any bracket, right? These terms added together. So all we've done here is add all the individual terms together. So range starting from x to 0, x to the power of 0, x to the power of 1, then all the way to the nth power, so the highest power of the bracket there, x to the n. Okay, and what we call this is, you might see it around somewhere, we call this the binomial theorem. So actually, this is a theorem that's been proven, that tells us this way of expanding a binomial. So again, a bracket that resembles this. We can expand it in this way. Okay. I should say as well, this is in the formula book, but when we go through the questions in this section, this video, and the next, hopefully start to pick up the method and the idea, because obviously at the moment this does look a bit weird, like it's just loads of terms together. I don't know what it means. When you go through examples in a minute, you'll see exactly how we put it in practice. But this is in the formula book, but like I said, I don't tend to memorise it. I don't recommend it, because you just pick it up anyway. But yeah, I think it's best to just jump through just some examples then, because that's the idea we're working with. So yeah, and also I should say as well, in general, if you ever need, you do work these binomial coefficients n choose r. Yes, calculate it on the calculator, but it's also given by the expression n factorial over r factorial of n minus r factorial. If for whatever reason you need that, we went over that last section as well, some examples relating to that, but that is also in the formula book. But try to compute this in the calculator, as we did last time in the last video as well. But yeah, let's just jump into some examples. And also, so this is in the formula book. you'd find it there under binomial series, and it's given basically the it's very similar sort of form to how I've given it. But you need to know how to use it, right? Because again, it looks like a bunch of gobbledygook. Without actually having to know what all these terms mean, which we're going to look at now. Okay, quick this question then. We need to use the binomial theorem. So again, the theorem is what this sort of idea that we talked about just by adding all the terms. Anyway, the binomial theorem to find the expansion of 3 minus 2x to the power of 5. Now, it's a very good idea in general to start with the lowest power of x, which should always be x to the 0, right? So remember, x to the 0 is still power, we start from 0. Now that term then, or I guess you can call the 0th term, it depends, the power of x will be 0, right? So x, we're going to have x to the 0, then but it won't be just x, will it? It'd be minus 2x. So minus 2x to the power of 0. Then times by the corresponding number 3 in the bracket. Now that'll be raised to the power of 5 then. Because the corresponding power, if it's 0 here, it has to be 5. Because 5 had 0, gives us the 5 there. Okay, so the powers have to match. And then we also have this coefficient part, which is n choose r. Well, n is 5 here, the power. And r is the power of x, which would then be 0. We could work that out, but I want to let me do all the terms first. Then, well, again, the next term is they're going to have a coefficient of 5 choose 1 now. And then the x power will then be minus 2x. Remember, not x, it's minus 2x here. And then that'd be a power of 1. So it going up in powers by 1. And then the corresponding 3 would have a power of 4 then. 1 add 4 is now 5. Then we do the next term. So that'd be 5 choose 2 of x, of minus 2x, sorry. To the power of 2 now. And then the corresponding 3 would have a power of 3. Then the next term, 5 choose 3. And then minus 2x would then be a power of 3 now. Then 3, the other number there, would then be a power 2. Then we do 5 choose 4. And then minus 2x would then be a power 4. So hopefully you recognise the power, the numbers are going up in our coefficient there corresponds to the power of the x part there. Anyway, and then the 3 would then have a corresponding power of 1. And then the last term, and I know it's the last term because now the numbers are the same in the coefficient, but also because then the power of x would then be 5, so which would match the power there. Anyway, so that's power of 5, then 3, the other number would then be a power 0 to match. And there we are. So that's all the terms. Now we just got to put all that in the calculator. I recommend doing it term by term. So I'm going to first work out the x to the 0 term, which I've underlined there. If I put that in the calculator, well, minus 2x to the power of 0 is just going to be 1. So that'd be nothing really. So we have 3 to the 5, which should be 243 times 5 choose 0. If I put that in the calculator. Remember we looked at how to use that in the calculator last time if you need to check how to put that in the calculator, that weird bracket, right? And that'd be 243 overall for the first term. We could say x to the 0, but again that's just 1. So that's just the constant term. Then we have the next term, which would then be minus 2x to the 1. Now, minus 2x to the power of 1 here, that'll just be minus 2 times x, right? So that'd be minus 2. Okay, then 5 choose 1. Minus 2 times 5 choose 1 is minus 10 then. Then we need to times by the 3 to the 4. That would be minus then 810, and that'd be an x tag to it there. Okay, then we got this term. So now we've got minus 2x squared, but I'm going to do the coefficient first. I'll do it in order. So then 5 choose 2, firstly, is 10. Then minus 2x squared, well that's minus 2 squared is 4, positive 4. So times that by 4 to get 40 then. Then times by 3 cubed, that would give me plus 1080, and that would then be x squared, okay? Then the next term here, well, 5 choose 3 is also 10, times by minus 2 cubed, but then be minus 80, then 3 squared will give us overall minus 720, but then we have the x cubed as well, okay? Then we have this part here, so then we have 5 choose 4, which should be 5, and then minus 2x to the 4, well that's x to the 4, but minus 2 to the 4, and so that'd be 80 overall. Yes, okay, we have 80, then we times by 3, well 3 to the power 1 is just 3, so just 3, that would get us plus 240 x to the 4, and then lastly we have this term. 5 choose 5 firstly is 1, then we have minus 2 to the 5 is minus 32, and then 3 to the 0 is just 1, because anything to the power 0 is 1, so overall we've got minus 32x to the 5, and there we are, that's our expansion. Now actually that is, once you get quick with the calculator and be able to do it a bit more quickly, you can work this out fairly quickly, and it's a power of 5, that's 5 brackets times together. If you did it the manual way, timesing it together 5 times, it'll be a hell of a lot longer than this, but there we are, that's the full expansion there. Okay, cool. This example then, it says now find the first 4 terms of the binomial expansion of firstly 1 plus 2x to the 10. So this time it's not asking for the whole expansion, I did the first 4 terms. Now what it means by first 4 terms is the first 4 terms are powers of x. So we start from x to the 0, then x to the 1, then x squared and x cubed. That's 4 terms, right? So that we only want to get to the x cubed part, okay? And so yeah. So first of all then, the x0 term, well, that's going to have a coefficient of, well, the power is 10 here. So 10, choose 0, matching the degree of the x part. But actually, it's not x here, it's 2x. So that'd be 2x all raised to the power of 0. Then the other part of the bracket is plus 1, so that'd be 1. Then that would be a power of 10, because then 10 matches with this 0 to get us 10 overall. Okay, then we add the next term, so then that'd be 10 choose 1 now. Then the power of x would be 1, so 2x all to the power 1. Then we have 1, then we have the 1 here times then by raised to the power of 9. Okay, so then 1 and 9 here, and here gets us 10. Okay, then the next term will be 10 choose 2, which would mean the x part, the 2x, right, would then be a power of 2. Then the 1 would then be a power of 8. And then 10 choose 3 for the next term. Then the 2x would then be a power of 3 now. Then the corresponding power of 1 would be 7 then. And actually that's 6, that's 4 different terms, right? So then we just put that in the calculator, do it term by term. So again, the first part there, well, 2x to the 0 is just 1. So then 10 choose 0, put that in the calculator, will be 1 as well. And 1 to the 10 is just 1, so overall we get 1 for the first term. Then we have this term, so 10 choose 1 now will be 10. So then 10 times 2x well, times 2, so 10 times 2 is 20. Then 20 times 1 to the 9 is 1. So we get 20. So that'd be 20x there. Then the next term here, well, 10 choose 2 is 45. Then 2 squared, which obviously comes from the 2x bracket here. So I should say as well, remember your index laws. So say here, 2x squared, we can raise the power individually. So that'd be 2 squared times x squared. Okay, so that's what I'm doing there. But remember your index laws, we can split the power up in that way. Anyway, 10 choose 2 is 45, then 2 squared from the bracket. So times that by, which is 45, times that by 2 squared, we'll then get us 180, then times by 1 to the 8, that's just 1 again. So overall, plus 180 x squared. Then the final part, the final term, my 10 choose 3 is 120. Then we have 2 cubed, so times by 2 cubed, you get 960. But then times by 1, that's just 1, so overall 960 x cubed. And there we are, so those are the first 4 terms there. Cool, okay, part B. Then we need to find 10 minus a half x, all to the power of 6. Okay, so it looks a bit messy this time with a fraction and stuff, but it's the same process. So the first 4 terms again, well, firstly we're going to start from 0, so we're going to have 10 choose 0, no, 6 choose 0, sorry, there's a power of 6, times the x part. Now the x part is minus a half x, so there we are. Then that would be to power 0, right, matching there. Then we have the corresponding term in there, 10, and that'd be then to the power 6 to match the 6 there. And there we are, so then the next term would then be 6 choose 1, then the minus a half x term would then be a power 1, then the 10 would then be a power 5 overall, there we are, to add up to the 6. Then the next term would be 6 choose 2 times by the minus a half x would then be a power 2, then the corresponding 10 would have a power of 4 there. Then this next term, 6 choose 3, then the minus a half x would be a power 3, then the 10 would have a power 3, okay, and that's 4 terms there, okay. So then we put all that in the calculator. So first we do the first term. Well, 6 choose 0 is 1, minus a half x all to the power of 0 is just 1 as well, so overall 10 to the 6 is a very big number. How many zeros is that? 1, 2, 3, 4, 1 million, I believe. Let me count that again. Yes, okay, 1 million. Then we have this next term here. Well, firstly, 6 choose 1 is 6. Then minus a half x to the 1, that's just minus a half. So times that by minus a half. So 6 then times minus a half is minus 3. Then we times by 10 to the 5. So that will give me minus 300,000. Then that'd be a power of, that's just x, right? X to the power 1, just x. Yep. Okay, then the next part here, we have 6 choose 2, that'd be 15, times by minus a half all squared. So then that 15 goes, times minus a half is, all squared is, 15 over 4, then times by 10 to the 4, we get plus 37,500 x squared. Okay, and then the final part, we have 6 choose 3, which is 20, then minus a half, all cubed, but then put that to minus 5 over 2, times it then by 10 cubed, will be minus 2,500 x cubed. And there we are then, that's the first 4 terms there, okay. Cool, so hopefully you start to get an idea of basically the idea of how to expand these, right. by the bracket first. Obviously start from r is 0, so we have n choose 0 here. Then times for the x term, then the other term in the bracket here is 10, and then we go from there each. So hopefully you start to get the idea, and hopefully you become more comfortable. Maybe not rely on the formula or whatever, but it will always be there in the formula book anyway. Okay, so have a look at some exercise questions then, now that we've got an idea of how to expand certain brackets. So, it wants us to find the first three terms of the binomial expansion of 2 minus x to the 6. So again, fairly standard what we looked at. Now that's for the first three terms. So it's going to be x to the 0, x1, and then x squared. Three terms of x there. Anyway, so if we expand this then, well, firstly, it's going to be 6, choose 0 firstly, so start from 0. Then the x term, well, it's minus x here, will then be 0. Then the 2 would then be a corresponding power of 6. There we are. Then the next term is 6, choose 1. And then minus x would be a power of 1. And then 2 would then be a power of 5 overall. And then this term, the next term is 6 choose 2, then minus x will be all squared then, so power 2. Then the 2, the number in the bracket would then be a power 4, so then 2 and 4 gets us 6. And actually those are three terms, so we're good. We can just simply expand it now, work it all out in the calculator. So this term then, well, 6 choose 0 is 1. Then minus x to the power 0 is just 1 as well, so then just 2 to the 6 is 64. Then 6 choose 1 then, so on this term now, 6 choose 1 is 6. Then minus x to the 1 is just minus x, so we have 6 times minus 1 is minus 6. Then minus 6 then times by 2 to the 5 will give us minus 192x. And then this term then, well, 6 choose 2 is 15, times by minus x all squared, well that's minus 1 squared, which is 1, so then 15 times 2 to the 4 is 240, so then plus 240 x squared, and there we are. Cool. Okay. And also remind as well, it's ascending powers of x, that's what we've done here. So the x powers go up, okay? But usually, it'll be like that pretty much every single time. I've never seen a question when descending powers of x or whatever. It will always be in that way, so don't worry about the question wording it like that. So ascending powers of x also means the powers of x increases in each term. So that was x to the 0, which is obviously 1. So no x there, then we have x to the 1, then we have x squared. Okay, so the powers of x are going up, but that's the whole idea of this method. It's designed to go like that anyway. So that's the question. And actually, final question now to finish off. The binomial expansion of x plus 1 over x to the power of 5, and it wants us to find each term, okay? So the full expansion. Well, there are two x's, but it's the same thing, really. So let's take x here first. So we have 5 choose 0, as always. 5 choose 0. Then let's take x here to the power of 0. That'd be our first x. Then the other term, 1 over x in the bracket. So obviously with the bracket, so I have to remind, x plus a, that's what we wrote at the start. Well, that's just two numbers, x and a. I could call that a anything I want. A here could be just 1 over x, okay? It could be absolutely anything whatsoever. But anyway, we have two terms that are added together in the bracket. Well, we start with x to power 0. So then the corresponding part of 1 over x would then be to the power of 5, okay? Then, the next part would be 5 choose 1, then x then would be a power of 1, then the other part 1 over x would then be a power of 4, then the next term is 5 choose 2, then we have x squared, then 1 over x would be cubed, Okay, then we have 5 choose 3. The next term, but then that'd be x cubed. Then the x to the 1 over x, and the other part would have a corresponding power of 2 to obviously get 5. Then the next term is 5 choose 4, then there'd be x to the 4, and then 1 over x would then be power 1. Then the final term is 5 choose 5, and then x to the 5, and then 1 over x would be a power of 0. Okay, cool. So now we just need to put all this in the calculator. Now it won't be as easy put it in the calculator. We can only, because we've got loads of x's, right? Obviously unknowns, the calculator doesn't deal with algebra in that way. So I guess we could, let me just put the coefficients in the calculator. So 5 choose 0 is 1. Well, x to the 0 is just 1 as well. So we just have 1 over x to the 5 for that term here. Then for this part here, 5 choose 1 gives me 5. So it's going to be 5x to the, and then 1 over x to the 4. We'll simplify that in a second. Then the next term, well, 5 choose 2 gets me 10. So there will be 10x squared, lots of 1 over x cubed. Then we have the next term, which is 5 choose 3, which is also 10. So we're going to have 10x cubed of 1 over x squared. Okay, then we have this term here, 5 choose 4, which is 5. So we're going to have 5x to the 4 times by 1 over x. Well, that's just power 1, so that's just 1 over x. And then 5 choose 5 is 1. So we have just x to the 5. And then 1 over x here is power 0, so that just goes to 1 as well. So we've just got x to the 5 there. Okay, well, we simplified it a little bit. We evaluated what we could on the calculator, so the coefficient parts, that weird bracket at the start. Now we need to expand the brackets because we've got 1 over x raised to powers. So if we expand the brackets then, that's just index laws again. So 1 over x to the 5 here, well, that's just 1 over x to the 5, right? Because again, that's 1 over x to the 5. You just raise that the top and bottom by to power 5. So 1 to the 5 over x to the 5. But obviously 1 raised to any power is just 1. So we just get 1 over x to the 5. Okay, that's just a recap of index laws. But yeah. So we have 1 over x to the 5. Then the next term here. So we're going to have 5x. But then 1 over x to the 4 is just 1 over x to the 4. So then that'd be times by 1 over x to the 4. Or we could just say 5x over x to the 4. Okay, then the next part, well, that's 10x squared. So 10x squared. Then 1 over x all cubed, well, that's just dividing it by x cubed, essentially, right? Then the next term here is 10x cubed times by 1 over x all squared. Well, that's just 10x cubed over x squared, right? And then the last, then this term here is 5x to the 4. And then that's just over x. And then lastly, we've got x to the 5. So then we can simplify it just one more time by just dividing the powers of x. So we got 1 over x to the 5. Okay. Then we have 5x over x to the 4. So if you remember index laws, if this is like x to the power 1, well then you subtract the powers, right? So 1 take away 4 is minus 3. Or we just say 5 over x cubed there. Then we have 10x squared over x cubed. That'll just be 10 over x, because x squared and x cubed gives me 1 over x. Then we have 10x cubed over x squared, so that's just 10x there. Then we have 5x to the 4 over x, that's 5x cubed, because 4 take away 1 there, obviously gives you 3. And then lastly we just got the x to the 5. And there we are. You could perhaps simplify it by rewriting it as indices. So you could say it's x to the minus 5, add 5x to the minus 3, add 10x to the minus 1, add 10x, add 5x cubed, add x to the 5 if you wish, but that wasn't necessary. It doesn't ask to give it in a particular form, just to simplify it. So that means simplify the fractions, essentially. But there we are then. So yeah, so hopefully you got now a flavour for how to expand binomial brackets. Now it's the same idea, right? Hopefully you notice that. The same sort of idea, the way we approach it. But we will look at more complicated problems relating to this next time. So how we can use the binomial expansion to work out other things, right? More trickier problems. But for now, hopefully you just got the base idea of how we can expand a binomial, right? Using this idea of the coefficient, start from 5 choose 0, say, start from 0, then x to the power 0, then obviously go on from there. So then you do 5 choose 1, then 5 choose 2, and then 5 choose 3, and then the x powers and all that follows. And so we get the expansion that way. And hopefully you notice it's a lot quicker this way than just expanding the brackets how you normally do. So it's a very, very powerful and useful method. But yeah, cool. So I'm going to leave that there then. I'll see you next time.